Hi everyone. Today we are going to start a new video series about electrical vehicles, and this is going to be an interesting topic. Hope you will enjoy it. And let us start with what is an electrical vehicle, why we need electrical vehicle, what are the types of electrical vehicle available in the market, how it differs from each other, and we are going to see the detailed information about the internal parts of these EVs in the upcoming videos. So let us start with a small question. So if you know the answer, please let me know in the comment box. A three-phase induction motor or a permanent magnet motor which has better efficiency. Why do I ask about these two type of motors? Because I'm going to or the company car manufacturers are using these type of motors in EVs most widely. So we must know which motor is having better efficiency, or the better for performance, so that why they choose these motors over other types of motors will be answered from that question. And the second question, how does the speed of an electrical vehicle changed? So in the fossil fuel mechanism, we know that by uh, pressing the accelerator, we are feeding the fuel to the engine. So the engine, how much fuel is coming, that much combustion takes place, that much energy is released. So based on that, the vehicle speed can be varied. How does it happens in the electrical vehicle? So that is the question. So if you know the answer for these two questions, please let me know in the comment box. So now let us see how the electrical vehicle works. So basically, we should understand what are the internal parts. So though I did not put the detailed one, so there is a basic elements here. So let us understand this. So later we will discuss each and every part in detail in the upcoming videos. So there is a battery charger which is used to charge the battery. So whatever the supply we are getting from the charging unit from here, it needs to be converted. Either if it is a AC supply, it needs to be converted into DC, or if it is the lower level voltages, it needs to be increased the level, and it has to regulate the voltage and current before it is going to the charger or the battery unit. So all this work is done by the power electronic charge controller or the charging unit, and which is called as a battery charger. And once it is regulated, and once it is step up or step down the voltage levels, then it goes to the battery, so where the electrical energy is stored. And sometimes we have the fuel tank, like a fuel cell, or if it is a pure electrical vehicle, we have a battery alone. So this energy whichever is coming through the charging unit, it will be stored in the battery unit. And when you want to run the car, so you are going to start the vehicle, and when you are starting the vehicle from the battery, the power is going to go through the inverter, and the inverter is the device which is going to convert the DC supply from the battery into AC supply, and this AC supply will be fed to the motor, induction motor, or it may be a permanent magnet motor. So this motor supply will be fed, and the accessories whichever need a DC supply directly, so that also will be fed to the devices. And once the machine is getting the power, and the machine going to start, and it is going to run, and there is a mechanism inside to vary the frequency of the supply which you are giving to the motor, three-phase motor. So based on that, the speed or the frequency can be varied. So when the frequency is varied, we know that induction motor speed can be changed. So based on that, the speed can be changed for this electrical vehicle. So once the motor is running, so it is connected to the transmission unit. So this transmission unit is connected to the wheels of the car, so that the electrical car start moving. So this is the general introduction about how the electrical vehicle works or moves. Now let us understand electrification level of electrical vehicles. So there are different level of electrification. So we have micro HEV, mild HEV, strong HEVs, PHEV, EREV, BEVs. So this is the graph from very lower level of electrification to pure electrical vehicle. So these are the different level of electrification, and there are few examples also given here. So in the micro HEVs, we achieve only start and stop operation using electrical signal, and in mild HEV we have the start and stop process, and there is a little bit of power assistance from the electrical motor, and regenerating braking also taking place whenever you apply a brake. And in the full HEV, we are going to have power assistance, regenerative braking, and also BEV driving mode is possible. So even the battery is fully charged, when you want to drive the vehicle in pure electrical mode, it is also possible. By the help of a clutch, we can just remove the engine from the transmission, so that the electrical motor itself can drive the device, so vehicle, right? So this is for full HEV. And PHEV, that is plug-in hybrid electrical vehicles. So it has power assistance, regenerative braking, and BEV driving mode, also plug. So that means you can charge these batteries by using the plug type, this one, right? And extended range electrical vehicles also has these capabilities: power assistance, regenerative braking, BEV driving, plug. And BEV, so where you have pure electrical vehicle based on the battery power which is stored, so where you have regenerative braking, BEV driving, and plug. So you can see here there is no power assistance because we are not going to use engine, so it is a pure electrical vehicle. And voltage ranges also given here. So in the micro HEV, we have only 12 volt battery, and mild HEV up to 48 volt or a little greater than that. And in full HEV, 200 to 300 volt batteries, either you connect them in series and parallel combination. And PHEV, we have 300 plus, EREV also we have 300 plus, and BEV also 300 plus. Voltage ranges are available for the batteries. And power 2.5 kilowatts to 60 plus kilowatts. This is the power ranges. And the efficiency, you can see the improvement of efficiency from 2 to 4 percentage, and it goes keep goes. And for BEV, greater than 60 percentage improvement can be achieved compared to the fossil fuel vehicles. So this is the electrification level of EVs. And different architectures are available based on the powertrains for the electrical vehicles. So we have battery electrical vehicles, so BEV, so which is purely based on the electrical charge stored in the battery. So there is no hybrid, there is no other sources, only electrical energy as source for this type of cars. Hybrid electrical vehicle, where we have two or three different type of energy sources can be used. Mostly it will be of fossil fuel and electrical battery. And we have plug-in type hybrid vehicles. So there is a difference between hybrid electrical vehicle and plug-in electrical vehicle. So plug-in electrical vehicles, these can be charged from our outlets, okay, outlet. But in the HEVs, mostly the energy will be the engine energy will be converted into electrical energy, and that electrical energy will be stored in the battery. So whenever we need the battery to support the vehicle for acceleration or deceleration, that time only it will be used for assisting. And sometimes if you want to run the vehicle purely based on the electrical also, it is possible in the hybrid electric type. Plug-in type, where we are going to charge this in a vehicle with a plug which is connected to the outlets. And fuel cell electrical vehicles, so these the energy source, we have a fuel cells, and these fuel cells we are going to convert the energy into electrical energy, and that electrical energy will be stored in the batteries, and then we are going to use them for driving the car. So these are the few different type of powertrain architectures available for this EVs. So let us have a comparison, fuel economy and range of EVs, so that we can understand them clearly. Let me take this highlighter. So range is a big problem for the EVs as of now, because we, as like fossil fuel, once you fill the tank, it is not going to go for a very long distance. So that is drawback, because amount of energy which we could able to store in the batteries is a question, and there is a developments in the battery field, where we are trying to improve the efficiency of the battery system, and reduce the size and the charging time and discharging time of the battery, and so many other performance factors. And let us understand how it is being compared here. So for the IC engine based cars or the vehicles, so the efficiency, fuel economy, that is miles per gallons equivalent. Miles per gallons equivalent is given in the x-axis, and range is given here. So almost we have 30 to 35 miles per gallons equivalent for the fuel economy. That means
35 miles per gallon equivalent. When we convert it into kilometers per liter, it will come around 15 kilometers per liter. That is the fuel
And
efficiency.
for the HEVs, you can see here that it is comparatively better for the fuel economy, as well as the range is more compared to the IC engines. Also, the range here up to 400 to 500 kilometers. For the hybrid electrical vehicles, since the battery as well as the mm, you know we have the fuel tank for running the car. So the range can be extended or increased, and the fuel economy also, it is better than the IC engine type. And then FCEV, fuel cell type electrical vehicles. So these fuel cell type electrical vehicles, comparatively, again the fuel economy also increased, and then the range is comparatively lesser than the IC engine and the hybrid electrical vehicle. But anyhow, the fuel economy is better for this type of devices. And battery electrical vehicles, that is BEV, pure electrical vehicles. So these electrical vehicles, you can see up to range up to almost around 150 to 200 kilometers. And fuel economy is also based upon the different type of manufacturers. The fuel economy also, it is more than the other vehicles. So there is, in summary, it is given here. The fuel economy for BEV is more than FCEV, and FCEV economy is more than HEV. HEV is efficiency or economy is more than ICE. So this is the fuel economy and range graph. And if you see this fuel economy versus trip length for BEV, you can see the length of the trip. So that means how much distance it can go, almost less than 100 miles. And the fuel economy is better. So here it is almost here it is MPG, so it is almost on to 110 or 120. And for PHEV and extended range electrical vehicles, it actually decreases from when you are increasing the trip length, then the fuel economy slowly decreases, and it comes to certain value here. And HEVs, hybrid electrical vehicles, it has a fuel economy, constant fuel economy, and the range trip length also, it is up to 200 uh, miles it is giving here. So this is the comparison for fuel economy and the trip length. So key components of an electrical powertrain, we have electrical machines, Powertronics. So the Powertronics means that DC to DC converter, AC to DC converter, regulators, and so on. So components, and energy management system, EMS, and energy storage system. So these are the major components of a electrical powertrain. So let us see what is there in the electrical machines. The electrical machines, we are having a different type of electrical machines which is used by different manufacturers for different reasons. And the first one is a permanent magnet motor type. And I have asked you the question in the first slide about this permanent magnet type. And the type of current which we feed for this motor is three-phase AC, and used in most type of EVs. The pros and cons of this type of motors: it has high efficiency, high torque, and the problem is short constant power range. So this is the pros and cons. And induction motor, the supply for this induction motor also is a three-phase AC, and these are the different type of companies they are using this type of induction motors. Induction motors, we know the characteristics: it is simple, robust, and wide speed range, and less efficient than the PM motors. So this is the drawback of this induction motor. It is not very less efficient motor, but comparatively, compared to the permanent magnet motors, the induction motors are having less efficiency. And the third option is a switched reluctance motor. So the supply which we need to feed to the motor is a DC, and still it is in the evolving stage only, so it is not widely used. And the advantage of this type of motors are capable of extreme high speed, but the problem is it is costly as of now. So these are the comparison of different type of electrical machines which is used in electrical vehicles. So I'm going to talk about this permanent magnet motor in detail in the upcoming videos. So now let us understand only what type of motors are being used. And for the powertronic part, as I said, we are going to have inverter. So the inverter may be different type. Okay, so we may have pure sine wave type of inverters, or we may have different type, multiple range type of inverters. And we are going to have DC to DC converter, which increase or decrease the battery voltages. And rectifiers, so we are going to have the onboard charges, convert AC from the electric grid to DC. So this is about a different type of powertronic components which is there inside the electrical vehicle. So only I'm talking about only the important or the bigger units. So there will be a lot of other elements as well to do a lot of works. EMS, energy management system, uses hardware and software control to optimize the energy efficiency and drivability. Software based high level supervisory control is also available in most of the electrical vehicles. And the energy storage system, that is the last important thing. So that the ESS could be a battery, that is energy storage system could be a battery, ultra capacitor, and hydrogen tank or fuel cell. So these are the different type of energy storage methods we use. Battery types used in EV: lead acid, nickel metal hydride, lithium ion type of battery. So these are the different type of batteries which is used in EVs. Now let us understand a little comparison between the batteries which are used in the electrical vehicles. So first one, LCO type batteries, that is a lithium cobalt type batteries. So there are parameters given for this type of batteries. The comparison is given. So the lifespan, safety, specific power, and specific energy, cost, performances. So all these parameters are compared for different type of batteries, so that so whichever is essential for that particular type of vehicle. So accordingly they can choose the type of batteries. Yeah, so for the LMO, so that is a lithium manganese oxide, is given here. So when you see this comparison, the specific energy is very high in LCO type of batteries, and when you see here LMO, we can see the specific power and specific energy and cost, performance, all of them are almost in a good range. But when you have specific energy as concerned, here it is very high for the LCO. And for NMC, that is lithium nickel manganese cobalt oxide type of batteries, again the specific energy and cost, performance, all these parameters is given here. And when you see about BYT electrical buses, LFP, so lithium iron phosphate. So here we can see the specific power, safety, lifespan, and these are the key important parameters, are the advantage parameters. And if you see, the specific energy is very less here, and cost moderate, and then performance also it is moderate, and it is used in BYD electrical buses. And Tesla model NCA type used nickel cobalt aluminum. You can see the specific energy lifespan is good, and performance is also better. The remaining things are in average range. LTU, so lithium titanium oxide. So here also this is also used in some bus, Proterra electrical buses. Safety is good, the lifespan is good, performance is good, and specific energy, and then specific power. These two we can see it is in average range, and the cost is less. So these are the different type of batteries and the comparison of these batteries. So this is the spec for the battery. Specific power means that the amount of power a battery can deliver per unit mass, typically measured in